This is the lesson for Chapter 7, Section 2, titled Multiplying Powers with the Same Base, day number 1. So let's take a look at our first type of problem that we'll end up seeing. And here we are asked to rewrite each expression using each base only once. And so the rule with multiplication is that if we have the same base, we can add up the exponents. It works this way. The reason is that 4 to the 5th would be 4, or 4 to the 5th is 5 4s being multiplied together. And then we have 3 4s being multiplied together with 4 to the 3rd, and that makes a total of 8 4s being multiplied. So the rule again is add up the exponents. And that's what we see here. So 4 to the 8th power is what they're looking for. So the next one, we are just doing the same thing. So since we have the same base, we add up the exponents. 2, 6, and 2 adds to make 12. So we have 2 to the 12th power. Over here, when I add the exponents, I need to make sure that I look at the signs in which I've got, and I've got 2 negatives, so I end up having to add those 2 together, and then add the positive 6, so I end up having to subtract from there. So this is the same thing as 5 to the 3rd power. So 6 plus 2 makes 4, minus 1 more makes 5 to the 3rd power. On this next one, when I look at these two terms, the 10 to the negative 4th is going to cancel the 10 to the positive 4th. You can see that because they make 0. And any number to the 0 power is going to end up being 1. And then we have still to the 2nd, so these two will cancel each other out, and I'm still left with that 10 to the 2nd power. So over on this one, we have 10 to the 9th, or 7 to the 9th, 7 to the 3rd, so I'm adding those two together, plus negative 10. So if I just add the 9 and the 3, I get 12, but then I have to add on that negative 10, and so I end up having to subtract since they are opposite in sign, leaving me with 7 to the 2nd power. So on this next one, 9 to the 2nd plus negative 8 plus positive 6. So when I add these two together, I get 9 to the negative 6th plus positive 6 makes 9 to the 0 power. And anytime you have anything to the 0 power, the answer is just 1. So let's move on to another type of problem, and here it says to simplify each expression. So to simplify just means combine any common bases that you have and count up the exponents. So z is the common base. I'm adding up the exponents. 8 and 5 give me 13. So it's z to the 13th power. So over here I multiply the two coefficients, negative 4 and 6. So I'm using the commutative property, moving the 6 next to the negative 4, and then counting up how many k's I have, k to the negative 3rd, k to the 4th. So I multiply the two coefficients there, I get negative 24. I count up how many k's I have, negative 3 and 4 make 1. So the answer is going to be negative 24k to the 1st power. And you can write it just like this. You don't have to put the exponent of 1, since every number has an exponent of 1. Next problem. So we do the same sort of thing. They have a different notation here with just the parentheses. We can still use the commutative property since everything's being multiplied together. So negative 5 and negative 3, and then b to the 3rd times b to the 6th. And so that makes 15b to the 9th power. Moving on to the next one, I move that 3 next to the 13, so that gives me 13 times by 3. And then I count up the x's. X to the negative 8th times x to the 10th power. And so I count them up. Well, first of all, multiply here, 39. And then x to the negative 8th plus 10 gives me 2. So 39x to the 2nd power. Over here I have negative 2 times by 4. I've got to move these next to each other and multiply them together. Negative 2 times 4. And then I've got h to the 5th times h to the negative 3rd. So I end up getting negative 8h, and then I have to add up the exponents. Negative 3 plus 5 gives me positive 2. So negative 8h to the 2nd power. And so a common mistake is sometimes people think, oh, I got a negative number, I need to switch its location. No, it's only negative exponents that you switch their location in the fraction. So on this next problem, the negative 8 gets multiplied by the 11, and then I count up the exponents. Now here we got to be careful. There's an exponent of 1 if you don't see it. So it's 1 plus 9 makes negative 88n to the 10th power. On the next one, you count up all the m's. So again, if you don't see an exponent, use 1. So m to the 1st plus 2 plus 1. So this is to the first power there, and then n's. N to the -2 plus -4 plus -1. And so we do that, we got m to the 4th power, 1, 2, and 1 make 4. N is going to end up being to the -3rd power. So we get -2 here plus -1 makes -3. So we're not done yet. Simplify, it says. So any negative exponents, we need to take the reciprocal. So m to the 4th over n to the 3rd power. So let's take a look at the next one. Here we have some coefficients. So 6 times -4, and then count up the a's. A to the 3rd and a to the 1st. So 3 plus 1, again that's to the 1st. And then we got some b's, b to the -2nd and -8. So we go ahead and multiply those coefficients. -24, a to the 4th, b to the -10th power. So again, just negative exponents go to the other part of the fraction. And so our answer is going to end up being -24, a to the 4th, all over b to the 10th power. So this one seems a little more complicated, just more variables. So we look at the coefficients. We've got 12 times -1. This is a -1 is the coefficient there, times by 2. Now count up the m's. So you got 1m here, 3 in that second group, and 1 in that third group. And then you count up the n's. You've got 1 right here, and then -2, and then that's it. And then we got just one p to the 5th power. And so multiply the numbers. We have -24. When I do that, count up the m's. We got 5 altogether. We got n to the -1st and p to the 5th. So now we just take any reciprocals, any negative exponents, just take the reciprocal, they become positive. So the answer is -24, m to the 5th, p to the 5th, and now down below you just have an n. You can write that as n to the 1st power or just n. So that's that type. Let's take a look at the last type of problem that we are going to deal with in today's lesson. It just deals with scientific notation. So what we need to remember about scientific notation is this, is that when we're dealing with it, it looks like this. It's in this form, a times by, and a is a number, times by, and then we have 10 to some power. I'll call it power of b. And so a is specific, though. A has to be between some numbers. So it's going to end up being from 1. It has to be either greater than or equal to 1. So it can't be any smaller than 1. So it can't be a fraction. Like it can't be 0.9 or anything like that. But then that value, we'll say the absolute value of it, has to be, and again, that's because if it was negative, you could have a negative number there, but it has to be less than or equal to 10. So the absolute value of a has to be greater than or equal to 1, but less than 10. It cannot equal 10. That means you can't have the 2 digits. The decimal point has to be after the first digit that you see. So that's the criteria. So let's just take a look at an example here. If it was 256,000, the answer would end up being, in scientific notation, 2.56 times 10 to the 5th power. 5th power because the decimal moves over 5 spaces. Let me fix that 5 real quick, make it look a little cleaner. So it's, again, over 1, 2, 3, 4, 5 spaces. And again, if the number was very small, like let's say 0.00034, the number would be 3.4 times 10, and then we use a negative exponent to represent this, -4. I got -4 because I go over 1, 2, 3, 4 to make it that number. So we're going to use that concept in this problem. So it says the population of a country in 1950 was 6.2 times 10 to the 7th power. And the population to 2030 is projected to be this many times the population of 1950. And then if the projection is correct, what will the population be? So we're multiplying because it says times. And so we're going to multiply this by 3 times 10 to the 2nd power. So it's the same as the other problems that we simplified. The difference is that we don't have the variables to deal with. So we're taking the 3 and multiplying it by 6.2. And then I'm taking the powers of 10, and I'm counting up how many I have. So I got 7 plus 2. So when I multiply this, I get 6 and 18. So 18.6 times 10 to the 9th power, but that's not in scientific notation. So when we're multiplying, oftentimes we're going to get this situation where the number's bigger than 10. And so we need to modify this. And so the way we're going to do that is we're going to move that decimal back one space. So basically what I ended up doing here is I divided this by 10. And so I'm going to change the color there so you can see that a little bit better. So I divided this 18.6 by 10. And so if I do that, that means I have to keep this in balance, I need to multiply the power of 10 by 10 to keep the number, the answer, in balance. And so I'm going to end up with 1.86 times 10 to the 10th power, and that's going to end up being our answer. So let's take a look at another one very similar to that. It goes this way. We've got, it says that the area of Rhode Island covers approximately this many square miles, and the area of Alaska covers a little more than this many times as much land as Rhode Island. And so we want to find the approximate area of Alaska. So 1.5 times 10 to the third. We're multiplying this by 4.3 times 10 to the second. And so when I do that, I'm just taking the coefficients, that 1.5 and the 4.3, and multiplying those two numbers, and then multiplying the powers of 10 together. 10 to the third, oops, not 10 to the 10th, but 10 to the third, and 10 to the second. And so when I multiply the two numbers here, I end up getting just 6.45. So I don't need to modify that number at all. And I just add up the exponents, so 10 to the 5th. That is the answer. So that is in square miles, miles squared. So those are the types of problems you're going to see on tonight's homework. Good luck.